Welcome to this tutorial on Kubernetes Labels and Selectors. In this video, we'll explore how labels help you organize and manage resources in your Kubernetes cluster using simple key-value pairs. Labels are fundamental building blocks that make it easy to work with hundreds or even thousands of Kubernetes objects efficiently. Labels are key-value pairs that you can attach to Kubernetes objects like pods, services, and deployments. Think of them as sticky notes that help you identify and categorize your resources. They're used to organize, select, and group resources, making management much easier. For example, you might have a label called App with the value Frontend, another called Environment with the value Production, and a third called Version with the value v1.2.3. These labels help you quickly identify what each resource does and where it belongs. When creating labels, you need to follow specific syntax rules. The key format consists of an optional prefix plus a name, like example.com/app. For key length, the prefix can be up to 253 characters, while the name can be up to 63 characters. Values must be alphanumeric and can include dashes, underscores, and dots, with a maximum of 63 characters. Valid characters include lowercase a through z, uppercase a through z, numbers 0 through 9, dashes, underscores, and dots. Keys and values must start and end with alphanumeric characters. Here's how you add labels to a pod using a YAML manifest file. In the metadata section, you define a labels block where you specify your key-value pairs. In this example, we're creating a pod named Web App with 3 labels: App set to Frontend, Environment set to Production, and Tier set to Web. The rest of the specification defines a container running nginx version 1.21. This approach allows you to organize your pods right from the moment they're created. You can also manage labels using kubectl commands after resources are created. To add a label, use kubectl label pods webapp version equals v1.0. To update an existing label, use the same command with a new value and add the -- overwrite flag, like version equals v2.0 -- overwrite. To remove a label entirely, append a dash to the label name, such as version dash. To view all labels on your pods, use kubectl get pods -- show labels. These commands give you flexibility to modify labels without editing YAML files. Label selectors allow you to query and filter resources based on their labels. They're essential tools for finding specific resources in your cluster. There are 2 main types of selectors. Equality-based selectors match exact values using equals or not equals operators. They're straightforward and commonly used for simple filtering. Set-based selectors are more flexible and use operators like in, not in, and exists. These let you filter resources based on whether a label's value belongs to a specific set of values. Equality-based selectors use simple comparison operators. The equal to operator lets you select pods where a label matches a specific value, like kubectl get pods -l environment equals production. This returns all pods where the environment label equals production. The not equal to operator does the opposite, selecting pods where a label doesn't match a value, like environment not equals staging. You can also combine multiple conditions using commas, such as app equals frontend, tier equals web. This selects only pods that match both conditions simultaneously, giving you precise control over which resources you retrieve. Set-based selectors offer more advanced filtering capabilities. The in operator selects resources where a label value matches any value in a specified set. For example, environment in parenthesis production, staging parenthesis, returns pods in either production or staging environments. The not in operator does the reverse, excluding resources with certain values, like environment not in parenthesis, dev, test parenthesis. The exists operator checks if a label key is present, regardless of its value. Simply specify the label name, like kubectl get pods -l version, to find all pods that have a version label. Labels have many practical applications in Kubernetes. For environment separation, you can distinguish between development, staging, and production resources, making it easy to manage different deployment stages. For service routing, services use label selectors to direct traffic to specific pods, ensuring requests reach the right application instances. For resource monitoring, you can group and track resources for metrics collection, helping you understand how different parts of your application perform. For rolling updates, labels help you manage deployment versions and implement rollback strategies, allowing you to update applications safely without downtime. To get the most value from labels, follow these best practices. Use consistent naming conventions across your teams to ensure everyone understands what each label means. Keep labels simple and meaningful, avoiding overly complex or cryptic names that confuse team members. Use prefixes to organize label namespaces, especially when multiple teams work on the same cluster. This prevents naming conflicts and makes labels more maintainable. Finally, document your label schemas for team reference, creating a shared understanding of which labels to use and when. These practices help you build a well-organized, manageable Kubernetes environment that scales with your needs.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.